Gravitational potential at a point is work done to bring a unit mass from infinity. Where is it? Work done to bring a unit mass from infinity to the point inside gravitational field. Okay, so this is a very straightforward definition. So gravitational potential is work done to bring a unit mass from infinity to a point to the point inside gravitational field. So the part B is Artemis is a spherical planet that may be assumed to be an isolated in space. The variation with distance x from the center of Artemis of the gravitational potential is shown in this figure. So what is given to us? On y-axis we have gravitational potential, and on x-axis we have distance from the center of this planet. So what do we have to find? The radius of this planet is 4,800 kilometers. Determine the phi, determine the value of phi on the surface of this planet. So if you look at this graph, you know the potential, gravitational potential at any distance from the center of this planet. Okay. So the radius of this planet is 4,800 kilometers. That is, radius is 4,800 kilometers. And on this axis you have distance, on this axis you have gravitational potential. So we have to read this graph to find the gravitational potential on the surface of this planet. So be careful about this scaling. That is, you can see from here, this is 10 to the power 7. So first of all, we should convert this R into meter. That is 4.8 into 10 raised power. This comes here 3, and we convert this kilometer into meter. That is 10 power 3. So which is 4.8 into 10 raised power 6 meter. So you have to read the graph for this value, that is 4.8 into 10 power 6. And you can easily see from this on this axis, that is, there are 20 boxes, and this is 0.5, 1, 1.5, and 2.5, so on. This is 0.5 into 10 to the power 7. Okay. So if we convert this into 10 to the power 7, we will get 0.48 into 10 power 7. Okay. So if 0.5 is here, then these are 10 small divisions. So one small division represents 0.05. Okay. So 0.48 will be equal to how many small divisions? So we can find this 0.48 divided by 0.05. That is 9.6 small divisions. So here you have 10, here you have 9. So 9.6 will be somewhere here, So you have to read the graph. 8, this 9.6. So if you read this graph for this value, you will get this value for the potential. And if this is 3.5 times 10 to the power 7, then one small deviation on the y-axis is, you can see from here, these are 10 small divisions and 10 small divisions is equal to 0.5. So one small division is 0.05. Okay. So if this is, let me, this is my point. So if this is 3.5, what would be this value? That is 3.55. 3.55. And be careful that the gravitational potential is always negative, and the negative signs are not written over here, but it is understood that the gravitational potential is negative. So the value of the gravitational potential on the surface of Earth is minus 3.55 times, you have to write this scaling factor as well, time 10 to the power 7. Okay, so this is one more question, and very straightforward. Be careful about the significant figures, and the rule for the significant figure is you have to write the least number of significant figures in each question in out of the significant figures of the raw data given in the question. Show that the mass of this planet is this. Okay, so how to find mass? If we, what do we know? We know gravitational potential, and we know its radius. So we have to find its mass. So you know that gravitational potential is minus G m over r. Okay. So put the value of gravitational potential, that is minus 3.55 times 10 power 7. The value of G is 6.67. You can see the value of G from the first page of this paper, that is minus 11 time mass we have to find divided by the radius, and the radius of this planet is 4,800 kilometers. Be careful to convert this kilometer into meter. Most of the students forget this. So that is 4,800 times 10 power 3. That is in meter. So if you will solve this, you will get the mass from this equation, that is 2.55 times 10 power 24 to the allowed number of significant figures. Okay. So I hope you understand that. Now let's move to the third part. Calculate the gravitational field strength G on the surface of this planet. So what's the formula of gravitational field strength? You know that gravitational field strength is G m over r square. This is gravitational field strength, and this is distance from the center of planet, and this is the mass of planet. So we have to find gravitational field strength on the surface of planet. So we have to put this r as the radius of the planet. Okay, and the mass of planet is already known to us, that is 2.55. Put this value of mass over here, and the radius is this. Then you will get the value of G, and that would be, you can easily put the values minus 6.67 times 10 power minus 11 into mass 2.55 time 10 power 24 divided by, what's the radius? The radius of this planet is 4,800 kilometers. So that is 4,800 times 10 to the power 3, that is in meter whole square. So if you will solve this, you will get the value of G gravitational field strength on the surface of the planet is 7.4 Newton per kg. Why I've written this into two significant figures? You can see the mass is given into the three significant figures, but this radius is, you can treat these two zeros, the last zero as significant or not. So this can be taken as two significant figure or four significant figure. Mostly it is in two significant figures. So we have to convert this G into two significant figures. Okay. So the last part is a satellite is in orbit at a fixed position above the point on the surface of this planet. We have a satellite that that moves around this planet, and the satellite is located above the equator of this planet at height above the surface where gravitational potential is given. So what do we know? We know this is the orbit of satellite. Okay, and we know over here the potential, gravitational potential, minus 0.65 times 10 power 7. We don't know this radius. So what do we have to find? We have to find the period of, time period in hours for the rotation of this satellite. So how do we find that? You know that we already know this thing. The gravitational force over here provides the centripetal force. So gravitational force is G m small m over r square is equal to mr omega square. This is the mass of this planet, the satellite, and the capital M is the mass of this planet. So we will cancel this and we will get Gm is r cube omega square. This is Kepler's third law. So we have to bring time period over here, that is r cube. We will place omega as 2 pi by T, you know that, is equal to Gm. So r cube 4 pi square over T square is equal to 0. And T square becomes 4 pi square r cube over Gm. To find time period, we need the radius of this orbit. And how do we find the radius of this orbit? What information are we given? We are given the gravitational potential at this point. The gravitational potential at this point. So, using the gravitational potential, we can find the radius of this orbit. And you know that the gravitational potential, the formula of gravitational potential is minus Gm over r. So that is 0.65 times 10 power 7 minus G M over R. So from this equation, we will find the radius of this orbit. Okay, that you can easily do. I will not waste your time in calculation. You just find R from this equation 1 and put that value of R over here to get the time period. You will get the time period in seconds because everything is in SI based unit. R is in meter. You will get R from this equation in meter if you put mass kg in this standard constant. And then you will get this time period in seconds. And after converting this time period from second to hours, you will get your answer around 19 hours. So I hope you can easily understand this question. So the recipe is very simple. Using, first of all, you should link this basic equation. You should think that the centripetal force is provided by the gravitational force. And if you remember the Kepler's third law, you can use this directly. And you know that the relationship between time period and the radius is given. So you should know the radius first. So for the radius, you are given this information. You are given the gravitational potential at this position. So you can find radius easily, and then you can put over here to get the time period in hours. So if you want time periods in second, that will be 6. The time period in second will be 66800 seconds. I hope you can easily understand. Now let's move towards C part. State one similarity and one difference between the gravitational potential due to the point mass and electric potential due to point charge. So we have to identify the difference and similarity between electric potential and gravitational potential. You know that gravitational potential is minus G M over R, and electric potential is 1 over 4 pi epsilon Q over R, where Q is the charge of the point charge and R is the distance from its center. You can see from these two relations that the electric potential depends on the sign of this charge. So if this charge is positive, electric potential will be positive. If this charge is negative, electric potential will be negative. Whereas gravitational potential is always negative. So this is the one main difference, that electric potential can be positive and negative, whereas gravitational potential is always negative. So this is the main difference. So what's the similarity? Both electric potential and gravitational potential are 0, 8, infinity, R equal to infinity. If you put R infinity in these two equations, you will get the values for both of these potential 0. So this is one important similarity. Both are 0, 8, infinity. Okay, so the difference is gravitational potential is always negative, whereas electric potential can be negative and positive. Okay, so let's move towards second question. State what is meant by an ideal gas. You know, what's the definition of an ideal gas? An ideal gas is the gas which obeys this equation. PV is equal to nRT. The gas which obeys ideal gas equation for all values of pressure and temperature, where T is thermodynamic temperature. If you will not write this as what is T, if you will skip this thing, you will get 1 mark. Or in other words, you can also write this, the equation which obeys this equation, PV is directly proportional to T. Here is the second question. A fixed amount of helium gas is sealed in a container. The helium gas has a pressure of 1 into 10 to the power, 1.0 into 10 to the power, 1.10 times 10 to the power 5 Pascal, and volume is 540 centimeter cube at temperature of 27 degrees centigrade. The data is given over here. The volume of the container is rapidly decreased to this. The new volume is this, new temperature is this, and new pressure is this. No thermal energy, this is an important keyword, no thermal energy enters or leaves the helium gas during this process. So Q is 0. Show that helium gas behaves as an ideal gas. How would you prove this? We have to prove that this is an ideal gas. So obviously, if this is an ideal gas, then this should follow or satisfy the ideal gas equation. What is the ideal gas equation? PV is nRT. So if this is an ideal gas, then PV of T should be constant. Number of moles are not being changed over here, R is the constant. So what do we have to prove? We have to prove PV over T for the initial condition. It should be, we will calculate PV by T in this case and PV over T in this case. And if we get the same answer, obviously we should get the same answer because we have to prove that this is an ideal gas. So pressure over here is given in standard SI unit. What do we have to convert? We have to convert volume from centimeter cube to meter cube. Most of the students forget that. So you know that 1 centimeter is 1 meter is 100 centimeter. So 1 centimeter is 10 to the power minus 2 meter. Okay. So 1 centimeter cube is 10 minus 6 meter cube. This is again very important. And the second important thing, we have to convert this temperature into from degree centigrade to Kelvin. That is 1 degree centigrade. We have to add 273.15. You know it very well. So calculate P over T for these both situations, initial and final, and you should get the same answer. Okay. So your answer should be around 1 P over T for this case, that is 1.10 into 10 power 5 into volume is 540 times centimeter cube 10 power minus 6 over temperature is 27 plus 273.15. This should be same as for this way. So this is 2 more question, very simple. The first law of thermodynamics may be expressed as delta U is Q plus W, where this is change in internal energy, Q is thermal energy supplied, and this is work done. Use the first law of thermodynamics to explain why the temperature of the helium gas increases. So we have to prove why the temperature increases. You know from this important condition that there is no thermal energy enters to this system. So Q is 0. So delta U will be equal to W. So pressure is, so the volume of the gas is, you can easily see that the volume of the gas decreases. So if the volume of the gas decreases, then the work is done on the gas by the surrounding. Okay, work should be done on the gas by the surrounding as the volume of the gas decreases. What will you write is work is done on the gas by as its volume decreases. If work is done on the gas and no thermal energy is being supplied, then internal energy should increase. Internal energy, work is positive, you know that. If the work is done on the gas, this W should be positive and internal energy should increase. Internal energy increases. So, if the internal energy increases, then temperature should increase. So, the temperature should increase. Third question, third part, average translational kinetic energy Ek of the gas is given by of a molecule. This is very important. This is average translational kinetic energy of single molecule, where K is Boltzmann constant and T is thermodynamic temperature. Calculate the change in total kinetic energy of all the gas, of the gas. So we know that average kinetic energy of an ideal gas is given by 3 by 2 kT, and there is no potential energy in case of an ideal gas. We ignore, there is no force between the molecules, so the potential energy of an ideal gas is 0. So change in kinetic energy of a single molecule will be equal to 3 by 2 K change in temperature. This is change in kinetic energy of a single molecule. And the change in internal energy of the gas will be change in kinetic energy of single molecule multiplied by number of molecules. So we have to multiply this change in kinetic energy of a single molecule with number of molecules. So first of all, we have to calculate the number of molecules. And for the number of molecules, you know that which equation we should use. PV is equal to NKT. These are number of molecules, pressure, volume, constant, that is Boltzmann constant, and T is temperature. So how you will calculate number of molecules? The number of molecules are same over here and over here. No gas enters or leaves during this process. So you can use this pressure, this volume, this temperature, or you can use these one. So multiply, put the values of pressure, volume, temperature, and this constant to get number of molecules, that is PV over KT. So we will use this first one. P is 1.1 into 10 is power 4, 10 to the power 5, sorry. So put these values 1.1 into 10 power 5 times volume, that is 540 centimeter cube to meter cube, 10 power minus 6 over this constant 1.38 times 10 power minus 23. This is given in the paper front sheet, multiply by temperature. Temperature is 27 plus 273.15. So you will calculate the number of molecules from here, that is around 1.435 times 10 power 22, and then you will put these number of molecules over here, and the change in temperature should be, the change is same if you find change in degree centigrade or in Kelvin. So 3 by 2 is 1.38 times 10 power 23 minus, and the change in temperature is, what is final temperature? Final temperature is 742. Initial temperature is 27. So change in temperature is 742 minus 27. 742 minus 27. The change will be same. If you will convert this in Kelvin, and then you will subtract, the change will be same. Multiply by the number of molecules that we calculated in this first part. So the change in total kinetic energy would be 212 joules. Very important question. Let's move towards C part. The mass of nitrogen gas in another container is 24 grams at a temperature of 27 degrees centigrade. The gas is cooled to its boiling point of this. The initial temperature of the gas is 27, then it is cooled to minus 196 degrees centigrade. Assume that all gas condenses to the liquid. Then the gas condenses to the liquid. The state is also being changed. First, the gas is cooled. The state is not changed from 27 to minus 196. Then the state of the gas changes. For this change, the specific heat capacity of the nitrogen gas is this. The specific latent heat of vaporization is this. Determine the thermal energy in kilojoule removed from the nitrogen gas. During cooling process and during condensation, thermal energy is always removed. Okay. So the total change in the energy that is removed is, first we will use this equation mc delta T, because during this case the state is not changed. Where C is specific heat capacity, M is mass, delta T is change in temperature. Then we will use M into L, latent heat of, and the state is changed. Okay, so latent heat of fusion. The gas condenses to liquid. Okay, so but we are given the specific latent heat of vaporization. Okay, over here we need latent heat of fusion, specific latent heat of fusion. And please keep in mind the specific latent heat of vaporization and specific latent heat of condensation is always same. So the mass, that is 24 gram, we should convert this into kg, that is 0.024 times specific specific heat capacity is 1.04 kilojoule, and we have to find our answer into of kilojoule in kilojoule. This is also in kilojoule. So no need to convert kilojoule to joule. Okay, I hope you understand that. Multiply by the change in temperature. The temperature is being changed from 27 degrees centigrade to minus 196. Okay, so what is the total change in temperature? Total change in temperature is 27 plus 196 degrees centigrade. Okay, so the change in temperature would be same if you will convert these individual values to Kelvin and then you subtract. Okay, this is a negative, so the change over here will become positive, plus 0.024 time latent heat of vaporization or condensation. Fusion is 199. So that will give us the total thermal energy that is extracted from this gas, and it would be 10.3 kilojoule. I hope you can easily understand. The question 3 is, an object is suspended from a vertical spring, and as shown in this figure, the object is displaced vertically and then released so that it oscillates, undergoing simple harmonic motion. Figure shows the variation with displacement x of the energy E of oscillation. On vertical axis, we have displacement, and on horizontal axis, we have displacement, and on vertical axis, we have energy. And we are given three graphs, P, Q, and R. Okay. You can easily see, you can easily identify that out of these three graphs, which graph represents kinetic energy, which represents potential energy, and which represents the total energy. And where is the total amplitude? From this graph, you know that over here, this is mean position, and this is the maximum position. This is the amplitude. From here, we can find amplitude. The kinetic energy, potential energy, and the total energy of the oscillations are each represented by this. State the energy that is represented by each of the lines P, Q, R. So, P represents total energy, that should not change. This is total energy. And the kinetic energy at the mean is maximum. So this R is kinetic energy, and this is potential energy. Very simple and straightforward question. At mean position, potential energy is 0, but kinetic energy is maximum. As you move away from the mean position, kinetic energy decreases and potential energy increases. So the total energy remains same. Then kinetic energy becomes 0 at this point, extreme position, and potential energy becomes maximum at this point, whereas the total energy should remain same. Okay, so we had to identify P, Q, and R, and I have done that. The object has a mass of this, determine the period of oscillation. So what do we have to find? We are given mass, that is, we will convert this mass into kg, that is 0.13 kg, and we have to find time 3. How can we do that? What else we know from this graph? From this graph, as I stated earlier, we can find the maximum displacement or amplitude from the, this is the maximum displacement or amplitude. And from this graph, we know the total energy. And the total energy you can easily read on vertical axis. You are given energy, and each small divisions on the vertical axis represent, there are 10 small divisions, and one small division represents 0.1. So this is 0.1. This is 6, 6.1, 2, 3, 4. So the total energy is 6.4. We know the total energy. So the thinking process should be, we know total energy, E total, we know amplitude x naught from this graph, and we have to find time period. This is 4-mark question. So how can we link all these three things, 4 things? You know that E total is, this is very important equation, half m omega square x naught square. So total energy is known, mass is known, x naught is known. From this equation, we will find omega. So omega square is 2E total multiplied by, 2E total divided by m x naught square. Once you get omega, then omega is 2 pi by t. So you will get time period. So first you will have to calculate omega. Then you will have to calculate time period. And for time period, you will use that equation. So let's do that. What's the amplitude from this graph? As I had stated earlier, this is the amplitude, maximum displacement. And from here, you can easily calculate and think about one small division. You can easily find that 10 small divisions represent the gap of 0.4. 10 divisions 0.4, one small division is 0.04. So you can read this as, and this is 1.5. So x naught is, from here you can read 1.5 centimeter. But you have to convert x naught into meter, okay? And E total energy is 6.4 millijoule. 6.4 millijoule. So omega will be square root of this 2 times E total is 6.4 times 10 power minus 3. Be careful to convert millijoule into joule. Okay. Divided by the mass, that is 0.13 times x naught square. And x naught is 1.5 centimeter, which is, if you convert this centimeter into meter, you will get 0.015 square. So first find omega, that is 20.9, and then time period from this equation is 2 pi by omega, which is 0.30 second. Very simple and straightforward question. I hope you can easily understand. And if you have a strong grip on your understanding of the course, then you are able to link that these questions with your previous understanding. State the cause of damping. So in this system, we have to find the cause of damping. You know that damping is due to external resistive forces. So if the force is opposite to the direction of motion, opposite to the direction of motion, then there will be damping. Or you can write due to external resistive forces. Let's do this part. A light card is attached to the object. The object is displaced with the same initial amplitude and then released. During each complete oscillation, the energy of the system decreases by this. In each oscillation, energy decreases by 8% of the total energy at the start of that oscillation. So after one oscillation, the energy remaining would be 92% of the starting energy. If 8% is being lost, then 92% is being left. Determine the decrease in total energy in millijoule of the system at the end of 6 complete oscillations. So we have to find the total energy that is left. No, we have determined the decrease in energy after first 6 complete oscillations. So how do we do that question? You know that in each oscillation, after one oscillation, energy left will be 0.92 times initial energy, 6.4 millijoule. So we have to find energy loss in millijoule. So no need to convert that millijoule into joule. This is energy after one oscillation. Okay. And after second oscillation, energy will be 0.92 times of that energy. That will be 0.92 square times 6.4. And after third oscillation, it will be 0.92 times of that energy. That will be 0.92 cube. So after 6 oscillation, it will be 0.92 power 6 times 6.4. This is the energy left after 6 oscillation. So what is the decrease in energy? That is the total energy at the start, which is 6.4, minus energy lost, that is 0.92 power 6 times 6.4. So you will get as 2.5 millijoule. Very simple question. State with reason the type of damping that card introduces into the system. You know, in your mind, it should come that there are 3 types of damping: critical, heavy, and light damping. And in case of light damping, oscillation will be there, and the amplitude of the oscillation will decrease slightly. And in this situation, the oscillation is being performed. You know that oscillation is being performed, and after each oscillation, decrease in amplitude is 8%. So the decrease in amplitude is not too much, and oscillation is there. So we can say that the damping is light damping. It is light damping, and we should, if you will simply write light damping, you will not get that one mark. You have to write reason as well. So light damping is decrease in amplitude is very small. Decrease in amplitude is very small. Okay. Okay, so let's move towards question 4. State Coulomb's law. This law is about the force between charges, and you already know that the force between 2 point charges, 2 point charges is directly proportional to product of charges and inversely proportional to square of distance between their centers, or you can write square of separation between them. You know this formula, that is 1 over 4 pi epsilon q1 q2 over r square. But you have to write this in the statement of words. B part, a charged sphere X is supported on an insulating strand. This is charged sphere X, and the strand is insulating. A second charged sphere Y is suspended by insulating thread so that the charge Y is in equilibrium at position shown. So this charge Y is in equilibrium because of the repulsive force of this sphere. They have same sign of charge, so this charge will repel this, and the weight of this charge and the tension. So the forces acting on this charge sphere Y are the repulsive force due to charge X, the gravitational force, and the tension in the string. The charges are given, and these are in nanocoulomb. The length of the thread is this, and this distance is also given. On figure, draw and label all the three forces acting on this sphere Y. So what are these three forces? The first force is gravitational force that acts in this direction, that is the weight of this charge, and electric force on this charge due to this charge, this is repulsive, and the tension. These are three forces. Okay, so you have to draw these three forces over here: tension, weight, vertically downward, and this is electric force. Determine the mass of sphere. This is 4-mark question. How would you find the mass of this sphere? So for mass, we should find weight, and for weight, we should find, as this is in equilibrium, we should first of all find electric force. If we will have electric force, then using equilibrium condition, resultant force as 0 over here, we will be able to find the weight of this object. So first of all, we need to find this angle. Why would we need that? For we know that this system is in equilibrium, this mass is in equilibrium. So, and this is right angle triangle. You can easily see the triangle over here. I am talking about this triangle. This is right angle triangle. So I can easily find that theta, and I know the hypotenuse of this triangle and opposite. So I should use sine of theta. Sine of theta is 0.080 divided by 1.2. So I will find sine inverse of this to find theta. Then I will find electric force. And electric force over here will be 1 over 4 pi epsilon naught Q1, that is 96, and we have to convert this charge into coulomb to find force in Newton. Nano is 10 power minus 9. times 64 power minus 9 divided by the distance between their center is 0.080. And the value of epsilon is taken from the first page of this paper. And if you will put that value over here, you will get the force, electric forces. The value of epsilon is 8.85 times 10 power minus 12 4 pi. And using this, you will find this force is 8.63 times 10 power minus 3 Newton. So electric force is this. So how do we find weight? You know that if you draw, the object is equilibrium under these three forces. So using the concept of AS physics, you can show that if you draw the forces using triangular method, the weight of object, then this is electric force Fe, and this is tension. If the system is in equilibrium, these three forces must form a closed triangle. They must form a closed triangle, and this is theta. We know this theta, we know this electric force, and we have to find this W. We don't need to find this tension. So this is right angle triangle. We can use tan theta, that is electric force over weight. So from this equation, you will find the weight. Tan theta is equal to F electric force divided by weight. So the weight of the object will be electric force divided by tan theta. You know theta, and as I have calculated over here, so you will put that theta and electric force from here. You will get weight of the object, and the weight of after finding the weight of object, you will find, if you know the weight of object, then you can find mass of the object. Okay, so the weight of the object is 0.129 Newton. You know that mass weight is m times g, that is 0.129, and g is 9.81. So mass is 0.129 divided by 9.81, and that is equal to 0.013 kg. I hope you understand that. Calculate the total electric potential energy stored between x and y. This is again very simple application. You know that electric potential energy EP is 1 over 4 pi epsilon Q1 Q2 over R. We know distance between charges, we know their charges, we have to find electric potential energy in this very simple question, very straightforward question. So if you will put the values of Q1, Q2 over 4 pi epsilon, you will get that as 6.9 10 power minus 4 joule. An electron enters the region between the parallel plates. These are two parallel plates. The potential difference between these two plates is 250, as one plate is grounded and another plate is applied with positive 250 volt. And they are separated by 18 millimeter, and electron enters from here. So state the direction of electric force on the electron when it is between the plates. First of all, you should know that the direction of electric field over here is from high potential to low potential. This is direction of electric field. And electric field lines should be parallel because the field between these two plates is always uniform. And the force on electron is in the opposite direction of electric field. The force on electron is in this direction, force on electron. Towards the upper plate, you can write towards the plate P. Determine the magnitude of force acting on the electron. You know that electric force is EQ. And electric field strength between the parallel plates is the potential difference across the plates. Electric field strength over here is delta V, the potential difference across the plates divided by this distance. So E is 250. This is 0, so 250 divided by distance should be converted into millimeter. 80 meter, 10 power minus 3. This is electric field strength. So electric field strength time charge of electron, and you know that the charge on electron is also given in the front page. So electric force on the charge electron will be 250 divided by 0.018 time charge as an electron is 1.6 times 10 power minus 19. So that is 2.2 times 10 power minus 15 Newton. So again, very simple question. Explain why the electron does not follow a circular path. For circular path, force should always be towards a single point. Force should always be perpendicular to the velocity. When electron moves in the magnetic field, it follows a circular path. But when electron moves in electric field, the direction of force will always be in upward direction. Over here, direction of force is this, direction of force is this, direction of force is this, direction of force is this. So the direction of force is not changing. The force is towards the same direction. It is not perpendicular to the velocity. To follow a circular path, the force must be towards center. So over here, force is not towards the center. Force is not perpendicular to the velocity. So that's why it will not follow the circular paths. Okay. So you will simply write the force is not always perpendicular to the velocity. Force is not always perpendicular to the velocity. Or you can write the force is always in the same direction. Let's move towards the next question, question number 5. Capacitor, a battery of EMF 12 volt. This is capacitor and this is resistor. The switch is initially in position S. Initially, the capacitor is charged. When you move this switch towards T, the capacitor will discharge through this resistor. Okay. So by connecting capacitor across 12 volt, you are charging the capacitor, and by connecting this towards across R, you are discharging it. The variation with log of Q in microcoulomb versus T is given by this. First of all, you should know that why the graph between log Q and T is straight line. During discharging, the charge variation across the capacitor is given by this formula, where R is the resistance, C is the capacitance. Q naught is initial charge and Q is the charge at any time. If you will take log, you know that Q versus T is not a straight line. So when you take log, you will get log of Q naught, and these are 2 multiplied. So using the property of log, minus T over RC, ln E is 1. So I've used product rule of log. So log of Q is ln Q naught minus 1 over RC into T. So you can compare with the equation of straight line that this is along x-axis, this is along y-axis. So gradient is minus 1 over RC and y-intercept is ln Q naught. So we have to find the capacitance, and we know the y-intercept, that is 2 point. You know, on y-axis the small division is 0.1, so 2.9. This is 2.9. So ln Q naught, that is y-intercept, is 2.9. And so initial charge is, taking inverse log, it will be e to the power 2.9. And the charge will be in microcoulomb. How do we know that? This is already mentioned in the question. So we will find initial charge. And after finding initial charge, we will use Q is equal to C, V to find the capacitance, which is equal to Q by V. We know initial voltage across the capacitor, that is 12 volt. So the charge would be 18.2 microcoulomb, and C Q by V, that is 18.2 divided by 12. This will be in microfarad. And if you convert this microcoulomb into coulomb, then the charge will be in farad. Sorry, capacitance will be in farad. So the answer will be 1.5 microfarad. So if you have to find the capacitance in microfarad and you know the charge in microcoulomb, then there is no need to convert that. Okay. So this is initial. Determine the resistance of this. From this graph, you can see that gradient is minus 1 over RC. Gradient is minus 1 over RC. And you know capacitance, you can find the gradient. So resistance can be easily calculated from this, this relationship. So for gradient, take any 2 points on this graph. You can take this point and you can take any other point which you like. Okay. So let's say we are taking this point. So use these 2 points. This is 4. And on y-axis, this is 1.9. And this is x is 0 and 2.9. So find gradient y2 minus y1 over x2 minus x1. And then using the gradient, you can find resistance. So gradient is 2.9 minus 2.9 minus 1.9 over 0 minus 4. So you can find gradient, that would be 0.25. Okay. So put that gradient over here, minus 0.25 is equal to minus 1 over R, and C is in 1.5 microfarad. Okay, now this is again very important, that You know that gradient will be on vertical axis, the charge in coulomb, microcoulomb over, this is in second. So ultimately, there is no need to convert this 1.5 micro into coulomb. So you will get resistance as, let me calculate. So resistance over here will be 1 over. Okay, so we have to find resistance in ohm, not in mega ohm. So we have to convert this capacitance into farad, that is 10 to the power minus 6. Then we will get this resistance in ohm. So resistance will be 2.6 into 10 raised to the power 6 ohm. Calculate the energy stored in the capacitor. You know that at time t equal to 0. So energy is, the formula of energy is 1 by 2 Q naught V naught QV. We know initial charge, and that we have calculated in the previous part, 18.2. 18.2 coulomb into minus 6 times 12, initial voltage is that. So 1.1 times 10 power minus 4 joule. A second identical capacitor, I'm sorry, a second identical resistor is now connected parallel with R. The switch is initially at point S, the capacitor is fully charged, and then move towards T so that capacitor discharges. On figure sketch to show the variation L and Q versus T. So what would happen if you will connect a second resistor with R in parallel? Would the total resistance increase or decrease? So the answer is total resistance will decrease. That will be half of the previous resistance. So if the total resistance decreases, then what will be the effect on that graph? You know that gradient is 1 over RC. If R becomes half, then the gradient will become double. C is same. So gradient is 2 times the previous gradient. And initial value, initial charge will be same because the capacitor is connected to the same power supply. So initial voltage, initial charge on the capacitor will be same. And the capacitor discharging time, as the resistance has decreased, so the capacitor will slowly discharge. So the graph will pass through the same initial point, this is the same, but the gradient will become 2 times the previous gradient. So if we are going to find or draw, we have to make the gradient double. So for this same, for example, this value of 4 seconds, the rise is same, sorry, the run is same, the rise in second case will be double. So if in previous case, it drops to 1.9 from 2.9, the drop is 1, okay? But in second case, the drop would be 2 as gradient is 2. So from 2.9, it would drop to 0.9. It would drop to 0.9. So you will have to draw this line. The gradient is double, initial value is same. So you have to draw that. Let's move towards question 6. A Hall probe is placed in magnetic field. Hall voltage is 0. Hall probe is rotated to a new position in magnetic field. The Hall voltage becomes maximum. So initially, we have to explain the observation behind that. We have to explain that observation. If you will place the Hall probe parallel to the magnetic field, the voltage will be 0. And if it is placed perpendicular to the magnetic field, the voltage will become maximum. Reading 0, reading is 0 when plate of plane of plane of plate probe is parallel to magnetic field. And it is maximum when it is perpendicular to magnetic field. Okay. We are given the formula for calculating the Hall voltage. You know that formula, BI over NTQ, and where N for silicon and copper is given. State the meaning of N. What is N? This is number of free electrons per unit volume. The hint is also given over here. Most of the students say this is number of free electrons. No, this is number of free electrons, number density of charge carriers, or number of free electrons per unit volume. You can say number density of charge carriers. They can be free electrons, or in case of semiconductor, they can be whole as well. Charge density of number density of free electrons. Explain why the Hall probe is made from the silicon rather than copper. You can easily see that Hall voltage is inversely proportional to N. And in case of silicon, the N is much smaller than the N for the copper. So the Hall voltage in silicon will be more than the Hall voltage in copper. Smaller value of, you can say smaller value of N, so greater Hall voltage. Now this is another important situation. Hall probe gives the maximum reading 24 millivolt when placed in a uniform magnetic field of density this. So for 32 millitesla, it gives 24 millivolt. The same Hall probe is then placed in a magnetic field of the flux direction, fixed direction in varying flux density. The Hall probe is fixed position so that the angle between the Hall probe and the magnetic field is the same, angle is not changed. So when the Hall voltage was maximum, so it is same as previous. The variation between the Hall voltage from T0 to 8.6 is given. The coil of the number of turns, these are number of turns, and this is diameter. Placed in the magnetic field, plane of coil is perpendicular to the field. Calculate the magnitude of the maximum EMF in the coil from T0 to T this. So we are given the Hall voltage, and Hall voltage is produced when Hall probe is placed inside the magnetic field. And we know for the Hall probe that it gives 24 millivolt for the flux density of 32. So 32 millivolt millitesla is produced for 24 millivolt. No, 32 millitesla magnetic flux density produces Hall voltage of 24 millivolt. And over here in the graph, we are given the maximum Hall voltage is, you can easily read, the one small division is 1, so it is 31 to 3. So And okay, so 36. These are five small divisions. I'm sorry, five small divisions. One is representing 2. So 32, 34, 36. The hall voltage, the maximum hall voltage is 36 millivolt. So we have to find how much magnetic flux density is when the hall voltage is 36 millivolt. Same hall probe is used. So let's say this is X. This is direct proportionality. So if you will calculate magnetic flux density from this relationship, 24x is equal to 32 times 36. X would be 48 millitesla. So flux density, the maximum flux density corresponding to this is 48 millitesla. Now you know that according to Faraday law, induced EMF is delta NBA over delta T. Number of turns is same, area is same, magnetic flux density is being varied. As in all voltage is varied, induced all voltage is changing. So this means that the magnetic field that produces the hall voltage is changing. Okay. So we have to find the maximum induced EMF that corresponds to N is same, A is same, delta B over delta T. That is the gradient. That corresponds to the maximum gradient. Maximum gradient will correspond to the maximum induced EMF. So in this part, the gradient, the steepness is smaller than that part. The gradient in this part is more than that. So we will find the change of magnetic flux density in this part, and we will use this time to calculate induced EMF. The idea is very simple. So number of turns is 780 and area is pi d square and d is half, r is pi r square, sorry, r is half of that. So 1.8 times 10 power minus 2 whole square time the change of magnetic flux density is from 48 millitesla to 0. The change is 48. Over time is this time interval, and you can easily read that. So putting those values of T will give you induced EMF. So T from here is 1.4 seconds. So if you will calculate T or read from the graph, it is 1.4. So the answer is 0.027 volt. Okay, so let's move towards question 7. A beam of light, white light passes through a cloud of cool gas. The spectrum of the transmitted light is viewed and contains a number of black lines. You know that if the white light is passed through the cool gas, the gas will absorb few photons that match, whose energy matches to their internal transition energy. So these photons will be absent from that spectrum, and they will be emitted from in any random direction. So explain why these dark lines are there. So we have to explain that. So photons are absorbed and electron is excited. After absorbing the photon, electron becomes excited. Photon energy is equal to the energy difference of two levels. Photon energy relates or represent to single wavelength or frequency, and electron de-excite in any and emits photon in any direction. This is the reason. So these are the levels of energy of electrons. The photon comes, and this photon, for example, energy of this photon is matches to the energy of this level. Then this electron will jump to the upper state. This photon will be missed. Some energy levels of electron in an isolated hydrogen atom is given by, this is energy versus levels. And this table shows the wavelengths of photons that are emitted in the transition to N2 from other. So what they represent, when electron jumps from here to here, it will emit a wavelength, light, photon. And from here to here, it will emit another wavelength. From here to here, it will emit another wavelength. So these are four possible transition to N2, and that's why we are given these four wavelengths. You know that the energy of this photon is delta E. Energy of this photon is E is hc over lambda, and emitted wavelength is hc over delta E. Emitted wavelength is inversely proportional to delta E. The least the change in energy, then the greatest will be the wavelength. So this wavelength corresponds to this transition because the energy difference is least, so wavelength is maximum. The energy associated with the energy level N2 is this. So energy over here is, in this level is given, and we have to calculate the energy in joule of energy level N3. We have to find this energy. This is E2 is given to us. We have to find E3. So E3 minus E2 is h Planck's constant, c speed of light over wavelength. And wavelength over here is 658 nanometer. 658 times 10 power minus 9. And this energy is given in electron volt. We will convert that energy into joule, and we will find E3. So E3 will be E3 minus, and this E2 is in negative, that will become positive. These two negative sign will make them positive, 3.4. This is an electron volt, so we have to convert this into joule, and you know that 1 electron volt is 1.6 into 10 power minus 19 is equal to, h is the Planck's constant, that is 6.63 times 10 power minus 34 times speed of light over this value. From here you will get E3 as 2.42 10 power minus 19 joule negative. Okay जी. So let's do question 8. Plutonium-238 is an unstable and undergoes alpha decay. Complete the equation to show the decay of this. Very simple, straightforward question. You know that alpha is, there are 2 protons. This is helium nuclei and 2 neutrons, very straightforward, 2, 4. So in any reaction, proton number should conserve and nucleon number should conserve. So here you have 94, these are 2, so it should be 92 and it should be 234. Very simple question. The power source in a space probe contains 0.874 kg of plutonium. Each nucleus of plutonium that decays emits this much mega electron volt of energy. The half-life of plutonium is 87.7 years. Calculate the initial number of nuclei in the power source. We have to find initial number, total number of nucleon or nucleus that are at the start, and we are given that the mass at the start is 0.874. As the nucleus decays, its mass as well as number of nucleon decreases. So at the start, the mass is 0.874 and the mass of one nucleus of plutonium is 238 nucleons are there. So 238 times mass of one nucleon, that is 1.66 times 10 power minus 27 kg. This is mass of nucleus. In kg. And we have this much mass, so we can find number of nucleus in that mass. Okay. So number of nucleons will be this much mass divided by mass of a single nucleus. That is, you will have to put that over here. So you will get the answer of number of nuclei at the start. So use your calculator to find that, which would be 2.21 times 10 power 24. Determine the initial activity. So we have to find activity, and you know that activity is lambda n. And lambda, you know that easily, the relationship of lambda with half-life is, lambda is ln2 divided by t half. So activity that is ln2 divided by t half-life time n. Okay. So half-life is known to us, that is 87.7 years, and we have to convert this half-life into seconds so that we should get activity in its standard unit. So ln2 divided by t half-life is 87.7 time 87.7 times 365 days are there and 24 hours And in each hour, you have 3600 seconds times number of nucleus at the start. You know that activity also changes with time. So to find activity at the start or initial activity, we have to use initial number of nuclei, and that is 5.54 into 10 to the power 14 becquerel. This is the standard unit. Use your answers to determine the initial power output from the source due to the decay of plutonium. You know that activity is number of decay per second. Activity is number of decay per second. And in 1 second, we have this much decay, and in each decay, we have this much energy. So to find the power, we have to divide that energy with 1 second, because in 1 second we have this much decay, that is 5.54 times 10 power 14 per second, time in each decay the energy produces 5.59 mega electron volt, mean 10 power 6 electron volt, and 1 electron volt, the energy, you can easily convert electron volt to joule by using the scaling factor, 1.6 times 10 to the power minus 19. So put this 1.6 times 10 power minus 19. So you will get that energy as the power output at the start will be 496 watt. The space probe will continue to function until the power output from the plutonium is source decreases to 65.3% of its initial value. Calculate the time in years for which the space probe will function. So what we are given the power. If the power decreases to 65.3 of its initial value, then it will work. So we have to use activity, that is A naught e power minus lambda t. And activity is number of decay per second. So 65% mean A over A naught is 0.653. So bring this over here and we will get 0.653 is equal to e power minus lambda t. So take log ln 0.653 is equal to minus lambda t. Ln E is 1 and the power comes down. So putting lambda in years, we need time in years. So we have to put lambda in years. Okay. So lambda is ln2 divided by half-life in years is 87.7. No need to convert over here. So this is 87.7, and put that lambda over here, you will get the time, and it is 53.9 years. Alternative power source uses energy generated from the radioactive decay of polonium-210. Half-life is much smaller than the previous one. The mass of needed for the same initial power output is this much. So we need this much mass to get the same power. So just what one advantage and one disadvantage of using polonium 210 as the source of energy. What's the main disadvantage? And what is the advantage? So advantage is, in this case, we have less mass. If we have less mass, so less energy will be needed to carry, will be needed to get probed into space. To get probed into space. What's the disadvantage? Half-life is very small. Half-life is shorter, will not provide power for the long enough. Half-life is shorter, so will not provide power for long enough. This is the main disadvantage. Question 9. Ultrasound is used to produce diagnostic information about the internal body structure. Explain how ultrasound waves are detected. So we have to tell the principle of the detection of ultrasound. So they are detected by piezoelectric crystal or transistor. You know that when the ultrasound strikes with this crystal, then it will generate electric signal. And the reverse is also true. When electric signal is applied to that crystal, it will vibrate. So as it strikes, sound waves causes shape change, or this vibration, this vibrates, okay, shape change or vibration. So as sound waves strikes with that, it vibrates, and vibration causes EMF, which is decayed. Vibration causes or generates electrical signal, EMF or electrical signal, which is detected. So we can detect electrical signal. So the electrical signal generated will have same frequency as ultrasound. And alternating voltage V varies with time t according to this formula, where V naught is peak voltage and omega is angular frequency. The root mean square value is 66 volt. The frequency of ultrasound is 4.3 megahertz. What's V naught? You know that this is again very straightforward question. Vrms in this sinusoidal signal is V naught over under root 2. So what we know RMS value, that is 66, and we have to find peak value. So peak value will be square root 2 times 66. Okay, so you can easily calculate using your own calculator, and that is in this case 93 volt. Be careful about significant figures. So omega is frequency is given, and frequency is 4.3 into 10 power 6 hertz. We have to find omega in radian per second. So omega is related with frequency by this formula. You know that omega is What's omega? Omega is 2 pi by T or 2 pi F. So omega is 2 pi F. Use this relationship to find omega. So put that value of frequency from here to here and you will get omega is 2.7 into 10 to the power 7 radian per second. Table contains information about air and soft tissue, air density, speed of ultrasound, and this is specific acoustic impedance. Soft tissue, we don't know its density, speed, and specific acoustic impedance. Determine the unit of specific acoustic impedance. Very simple question. You know that specific acoustic impedance is product of density of the medium and speed of ultrasound in that medium. So you can easily calculate the unit from here, that is density is kg per meter cube and speed is meter per second. So you can easily work out to calculate the unit, and which is kg m minus 2 s minus 1. So one more question. Calculate the density of the soft tissue. For the soft tissue, you know specific acoustic impedance, speed of ultrasound, and you have to find density, and density is for the soft tissue will be Z over C. And for the soft tissue, Z is 1.7 into 10 to the power 6, or speed over here is 1600, speed of ultrasound in that medium. So the density will be 1100 kg per meter cube. Use data from the table to explain why the ultrasound can't be used to produce an image inside an air-filled activity such as in lungs. Okay, so we have to compare the specific acoustic impedances of air and soft tissue. You can see that there is a huge difference, and reflection coefficient is Z2 minus Z1 whole square over Z2 plus Z1 whole square. So if you will calculate reflection coefficient for these two medium, you will get this as you are given the specific acoustic impedances of these two medium. And if you will calculate this, you will get this alpha around 0.99. So if the large value of alpha indicates that there will be total reflection. If alpha is smaller, then reflection is smaller, transmission is maximum. This is reflection coefficient, the fraction of intensity that is reflected back. So if alpha approaches to 1 or close to 1, then the maximum intensity of ultrasound will be reflected back. So that's why we can't do ultrasound of our lungs, because for ultrasound diagnosis, the ultrasound should travel into the body. Question 10, the last question. A student observed different stars from the Earth. Give two reasons why some stars appear brighter than the others. So student observing stars, we have to find the reasons why some stars appear brighter. The first one reason can be the brighter star could have greater luminosity. Luminosity is the total power emitted by a star. So each star will have different amount of luminosity. So that's why they will appear different. So this is the one reason. And brighter star is hotter. The distance, the second difference will be the distance of the star from the Earth may be different. State what is meant by stranded candle. Stranded candle is known as object with known luminosity. Luminosity. A spectral line from a star with a galaxy is observed to have wavelength of this. The same spectral line measured in the laboratory have the wavelength of this. This is the actual wavelength, and 660 is the observed wavelength. Show that the speed of the star is given by this. This is the Doppler shift question. Doppler effect states that you can find change in wavelength over original wavelength. Change in wavelength over original wavelength is V by C. Okay. So this will have no unit, so no need to convert into nanometer, into meter from nanometer. So the change in wavelength is 660.9 minus 656.3 divided by original wavelength is 656.3. That is speed over speed of light is 3 into 10 to the power 8. So from here you can easily calculate that the speed of the star is given by this, that is 2.1 into 10 to the power 6 meter per second. Calculate the distance to the star. Calculate the distance to the star. The Hubble constant is this. You know that for this purpose you will use Hubble law, and that states that speed of recession is Hubble constant time d. And we have to find d, that is speed over Hubble constant. So speed we have calculated in the previous part, divided by Hubble constant is given in the standard unit. So distance of that star from the Earth will be, if you will calculate that, you will get 9.1 into 10 to the power 23 meter. State and explain what can be concluded about the universe based on this change in the observed wavelengths. You know that the wavelength over here has increased. Light is redshifted. So this shows that galaxy is moving away from Earth. If it is moving away from Earth, this proves that universe is expanding. Okay. So that was the end of this paper. I hope you understood each and everything. If it was helpful to you, then you are requested to subscribe my channel and share it with your friends so that everyone can get advantage. Thank you for watching.